Hello friends, this is Ankush Bhat with Catia tutorial number 22. In this tutorial, we will learn about the pocket tool of the part workbench. On the left hand side, we have Catia V5 window, and on the right hand side, we have step-by-step instructions for the tutorial number 22, which you can write down. So let's start by creating a new file. Go to Start, Mechanical Design, Part Design. Give a file name to your file, as I'm giving it Jimmy. So a new file with file name Jimmy has been created. This is the part workbench and these are the tools on the right interface and the top interface. This is the pocket tool, and by clicking at the bottom arrow we will get different type of pocket tools, and this was the pad tool, and these were the other type of pad tools which we learned in our previous video. So let me tell you about pocket tool in brief. The pad tool and the pocket tool, they both work, or we can say they both operate in the same way, or they both can be applied in the same way, but the only difference is that pad tool is used to add material to a sketch or to convert a 2D sketch into a 3D model. In the same way, the pocket tool is used to just to cut the material, as you can see by the symbol only. It doesn't add material to the sketch, it just cut the material through the solid with the help of that sketch. So let's see how it works by creating a 3D model. Just choose any plane from the part tree, as I'm going with XY plane, or you can choose the plane from here also. Now select the sketcher tool. Let's create a circle, a rectangle, and let's have a hexagon. So now let's exit our workbench. Let's pad these sketches. Now we can see we have converted a 2D sketch into a 3D model with the help of pad tool. So opposite to that, we use pocket tool to just cut the material, but they operate in the same way. Let's create a sketch on the surface. As we have learned in the previous video, just select the surface. Now select the sketcher tool, create a sketch, as I am creating a circle. As our sketch would be the profile of the cut, we can see. Now choose the pocket tool here. Now we can just define the type of pocket, like how we want to cut our pocket. Like either we want to give the dimension by selecting that dimension, like either we want to give dimension by giving the depth of the cut, as by increasing it or by decreasing it. We can prove that it has cut the material with the circular profile or the profile which we had sketched on the surface. Now just up to the next, in this type it cuts the sketch up to the next surface of the solid. We can see here this is the next surface of the hexagon. So by proving it, we can see it has cut the solid up to the next surface, up to the last, and up to the next give the same result. Up to the plane, with this option we can choose a plane, or we can choose a limiting plane up to which we can make a cut. Just choosing this plane, we can see we have formed a cut up to this plane. Just preview it. We can see we have formed a cut up to that plane. Now up to the surface means we can choose a limiting surface up to which we want our cut to move. Like I'm choosing this surface, or I can choose this surface. Like I'm choosing this surface. So we can see that we have created a cut up to this surface. So this is how the type works. So now let's create a pocket with the help of dimensions. So now moving on towards to the thick, we can use thick to just provide a thickness to a pocket. Like we can see, we can provide thickness 1 and thickness 2 With the increase in thickness one, we can see the inner thickness of the pocket is being increased. We can see here the inner thickness is increasing, or if by decreasing with thickness 1, the inner thickness is decreasing, and by increasing with thickness 2, the outer thickness is increasing, and with the decrease it is decreasing. So we can prove how it looks. So this is how the thick tool works. It works same as the pad tool, but it just removes the material instead of adding the material. Now let us study about the mirror extent by creating a sketch on this second profile. Let's have a sketch on this surface. Let's make a circle. We can see we have created a sketch. Let's pocket the circular profile. So by using mirror extend, we can see that we can create a cut on the both sides with the same dimension, and by providing the dimension, as these both sides take dimension uniformly, we can see. Or if you don't want to like dimension these both ends with the same dimensions, we can use thick tool and just provide the second limit here, the depth. By that we can provide the depth on the both sides uniquely, as it's 78 and on the other side we have 54. We can prove it. So we can see that we have created a thickened, like we should increase the thickness, prove it. So we can see we have created a thickened pocket on the both sides. Okay, so now let's see how merge ends work. For that we need to create an open sketch on the surface. Let's create on the surface. Select the surface, select the sketcher tool. Now let's fit in all. Let's create an open sketch on the surface. This is the open sketch. Select the pocket tool, go to thick. Just we can see we have created a thick pocket here. We also, with this way, we also learned that we can create a pocket with an open profile also. Now if we merge the ends, we can see that we have created a pocket up to the next surfaces, or if we didn't merge the ends, we had this type of pocket. But by merging the ends, the ends of the pocket has been merged with the end surfaces. Here we can see. So this is how pocket definition works, and all the operations of pocket definitions work. I hope you like this video, and thanks for watching this video.